Hi guys, welcome to Little Wicket Railway. I'm Rob and this is the third and final part in the series on using Arduinos with CMRI in JMRI to control a layout. Sorry there's been quite a delay in getting this out, but it's here now. If you haven't seen parts 1 and 2 already, then you might want to go back and check those out now because we'll be building on what we did in those videos. I'll put a link up here to part 1. Alternatively, you can keep watching this, see whether it's something you're interested in, and then go back and watch it if it's something you'd like to explore further. In part 1, we set up the Arduino Mega with a sensor shield as a CMRI node in JMRI and used this to read sensor inputs. In part 2, we added outputs for servos and things such as lighting using relays and MOSFETs. And in this part, we're going to set up multiple CMRI nodes and have them all working alongside each other. So rather than having one central node with wires going off all over the place to all the inputs and outputs, instead, we're going to create a CMRI network, a bit like a DCC bus, but for your CMRI connections. The CMRI network will connect to your computer using a single USB connection, and then we can connect nodes to wherever we need them on the CMRI bus. I've broken this video down into steps and I've listed them all as chapters in the description below so you can jump around as you need to. I've also put affiliate links to all the tools and components that I'm going to use down below the video too. We're going to start by constructing our CMRI network and connecting it to a computer. Then we're going to test that that works by adding 3 CMRI nodes, and for a bit of variety I'm using 3 different types of Arduino. The first node will be an Arduino Mega with a sensor shield because we're familiar with that from parts 1 and 2. Then we'll add an Arduino Uno as our second node with a light sensor on it just to prove that it works. And then we'll add an Arduino Nano as our third node, again keeping it simple with just a single light sensor to prove that everything works. Before we get started, please consider subscribing to the channel. I really appreciate it. It's totally free and it helps to support the channel. And also, if you hit that notifications button, YouTube will let you know when new videos come out in future. Okay, let's get started. Okay, so the first step is to create our CMRI bus and connect it to the computer, and for this we're going to need a USB to RS485 adapter. And you don't need to worry too much about what RS485 is or how it works, except that it's a standard electrical interface that allows us to create a network that can be up to 1.2 kilometers long, which should be more than enough for most model railway layouts. I'm using this adapter, which was about £10 on Amazon. I put a link in the description, but there are plenty of adapter options available, some more expensive and some cheaper. All we need to do is plug this into a USB connection on the computer that's going to be running JMRI. So that's plugged in and we've got a little light on there that shows us it's connected. So the next thing we need to do is to connect our CMRI network wires, and for this I'm going to be using yellow and green coloured wire. So on the adapter you'll see that we've got 2 connections labelled A and B. These are going to be our CMRI terminals, so I'm going to connect yellow wire to connection A and plug this into the top row of pins on this breadboard, which is going to be my test circuit, and this is going to be a really miniature version of our layout which we can plug all our nodes into and make sure everything works. And the B connection on here I'm going to plug into the lower set of pins, and you'll see I've linked all of these pins along the top up using these little joiners, and all of these lower set of pins are green, so that's going to be our B set of pins, so we can plug into anywhere on here for our CMRI connections. So that's the hardware for the CMRI network set up and ready to connect nodes to. But now we need to have a think about power supplies. So before we connect up nodes, we're going to have a think about power supplies. And I've got these 2 variable voltage power supplies, one set to 5 volts and one set to 12 volts. So let's plug in the 5 volt one over here. Again, we'll have the top set of pins as positive and the bottom set as ground. And I'm not going to plug this in just yet. And then here's our 12 volt supply, and that can be this side. So we'll plug, again, positive into the top and negative into the bottom row of pins. Again, not plugging this in just yet. So now we've got 2 sets of power. The 12 volt supply can power all the Arduinos that we're going to be using, and the 5 volt supply can be for the PCA 9685s or the sensors or basically anything else that needs a 5 volt power supply. So we've got the CMRI network and we've got the power supply, so let's connect up our first node. Before we start, if you want any more information on how to use CMRI and JMRI together, there is loads of information on the JMRI website. And there is also a really helpful diagram that shows all the connections that we're going to use in this demonstration. So I will leave a link to this in the description below. Okay, so the first node that we're going to plug in should be familiar. It's the Arduino Mega with the sensor shield on top that we've been using in parts 1 and 2. We've still got the IR sensor plugged into setter pins number 3. We've got the PCA 9685 plugged into the SCL and the SDA pins, and we've got the servo plugged into position number 1 on there. And then plugged into setter pins 46, we've still got our MOSFET driver board, which we'll just pop down here with the LEDs attached. Okay, so before we can connect this to the CMRI network, we're going to need one of these modules. It's a TTL to RS485 module, and I got 5 of these for just over £1 each on Amazon. So this module goes between the CMRI network and the Arduino. So let's get it wired in, and these are the connections that we need to make. So I'm going to pop it on my breadboard. Hopefully it will just slot in there. So over on this side we've got 4 pins. We've got positive VCC, we've got the B connection, the A connection for our CMRI bus, and then we've got a ground connection. So let's get that plugged in first. So again, using yellow for the A connection, we can pop that into there and connect it to the yellow bus at the top, and we'll use green for the B to be consistent. So that's it connected to the CMRI bus, and then let's plug in some power. So we've got the ground connection over here, and this takes a 5 volt supply. So this goes into here on our 5 volt supply. Plug in the positive. And there we go. So that's all the connections on this side of the board done. Now let's look at this side. So we've got 4 connections here. We've got DI, DE, RE and R0. The first thing we need to do is connect DE and RE together, and for this I'm using a really small little jumper wire. So that can go into there just to connect those pins together. Now, if you remember, we kept sets of pins 0, 1 and 2 free on our sensor shield, and that's because we need these to communicate with our RS485 to TTL module. So we've got some connection wires here. So the first pin we're going to connect is the R0, and that is going to connect to the RX0 signal pin on here. Then we're going to connect the D1 pin on here to the TX signal pin. Pins come off there. So that's on setter pins number 1. And then we're going to connect the DE and RE pins, which have been joined together. And that's going to be connected to the signal pin on setter pins number 2. And if you remember, in the sketch, that is the pin that we defined for our communication. So we've got the R0 pin attached to the RX pin, we've got the D1 pin attached to the TX pin, and we've got the DE and RE attached to signal pin on setter pins number 2. So now we need to add in some power. So the first thing we need to do is connect the sensor shield to a 5 volt power supply. So let's get that plugged in over here. and our MOSFET driver board needs a 12 volt supply, so let's get that plugged in over here. The PCA 9685 board needs a 5 volt power supply, and previously we've used this little terminal on top, but you can use this V plus pin over here. So I'm going to plug that into a 5 volt supply over here. And the only other thing we need to do is provide power to the Arduino. And previously it's got this power from the USB connection, but we're not using a USB connection this time. So it needs to get its power from somewhere else. And for this, I've got one of these 2.1mm adapter plugs. So that just plugs into here. And then this needs a 12 volt power supply. So we'll plug that into there and that into there. So as you can see, there's going to be quite a few wires on the board, especially when we add modules 2 and 3. But hopefully you followed what's going on. So let's plug in our power supplies and see whether everything lights up as it should do. So that's all looking good. We've got power on the Arduino, we've got power on the sensor shield, power on the PCA 9685. I heard the servo move, which is a good sign. I can see that the IR sensor is working here, and we've got a little light on the RS485 to TTL module. So let's go over to JMRI and see whether we can set this up and get it working. So we've got JMRI open. Let's go to Edit, Preferences, and our CMRI connection. So that COM6 is the COM port for my RS485 USB adapter. So hopefully your computer will have assigned a COM port to that adapter and you can select it from the drop down. Check that your baud rate settings are as per the sketch, so all of our sketches for all of our nodes are going to be 19,200. Then hit configure nodes, and in here you'll see that we've still got our node from part 2, which is an SUSIC, 32 bits per card, 2 input cards and 4 output cards. So you need to check that that's in there or this won't work. And that is crucially on node address 1. So our extra nodes that we're going to add later are going to be on node 2 and node 3. So hit done, hit save, and now we're ready to go to tools, tables, and let's start by adding our turnout. So in here, just like before, we're going to go CMRI, add its hardware address 1001 because it's on node 1 and we said it would be position 1. So let's see, call that turnout 1, hit create, use 1 bit, use steady state output. So hopefully when we press this, but there we go, that's all working. So let's go to the sensor, go to CMRI, hit add. Again, this was on 1001 and you'll know that from the previous sketch, the previous part. Let's call that SN1, hit create, and we'll see that it's already gone to active, and if we lift it up, it's inactive. Again, I can make that active and inactive. So our sensor's working, and finally let's go to our lights, and CMRI add, and I think this was on hardware address 1101. LT1, just to give it any old username, hit create and close that. Can we turn on our LEDs? Yeah, there we go. Those LEDs are lighting up. So that's node 1 attached, and this time not through a USB connection, but it's going through our CMRI network. So let's now add a second and third node. For node 2, I thought we'd use an Arduino Uno for a change, and just plugged into this I've got a light sensor which has got 3 pins on it, a power supply, a ground and a signal pin. So I've plugged the power into the 3.3 volt connection on here, I've plugged the ground into the ground pin, and I've plugged the signal pin into pin number 3. And then onto this Arduino Uno, I've uploaded a really basic sketch. So this is the sketch that I've uploaded to the Arduino Uno. We've got our 2 libraries included here at the top. We've given it node address 2, and then I've just defined a sensor on pin 3, and we've got our communication pin on pin 2. Here we are creating the CMRI node, so we've got the node address of 2 being pulled in there. We've got 24 inputs, 48 outputs, and then here we're setting our sensor pin, which is pin 3, to be an input. We're beginning the bus on our baud rate of 19,200. Then here is our really simple loop. All we're doing is reading digital pin 3, and this will be on address 2001 in JMRI. Okay, so let's get the Arduino Uno wired up. So let's pop that over there. And for this, again, we're going to need one of these RS485 to TTL boards. So let's pop this over this side. Again, the first thing we need to do is connect it to the CMRI bus. So I've got my yellow wire here. That goes in the top set of pins, and that goes to connection A. Then I've got my green wire. That's going to the B connection. And then that's going to connect to the Uno. So we will connect to the R0 to RX on here, which is pin 0. Again, DE and RE need to be jumpered together. So I've got one of my small jumper wires there. And then the D1 connection is going to go to the TX connection on the Uno, which is pin 1. And then the DE and RE, which have been linked together, can go to pin number 2, because that's what we defined as our D communication pin. Now we need our power supplies again. So we need 5 volts for the TTL module. And connect the ground to the 5 volt supply as well. And then, as before, our Uno needs power. It's not going to get it from the USB connection, so we need to use a 12 volt power supply. Again, I've got one of these 2.1mm plugs, so let's slot that in there, and then see if we can bring these wires round. Maybe if we turn this round. So red goes in the top. And there our Uno has power, and we've got our sensor here. And we can see that the sensor has power. When I put my finger over it, the little sensor light goes off. So now let's go back into JMRI and see whether we can add this. So in JMRI, now it's time to add our second node. So let's go to Edit, Preferences, go to CMRI, Configure Node. There's our first node. We'll hit Add Node. It's node address 2, and it's a node type SMINI, and that's what this CMRI type is. It's 24 inputs and 48 outputs. That's an SMINI. We'll give it the description Uno, and make sure Enable Polling at Startup is ticked. So hit Add Node, click Done, and hit Save. And it's always a good idea to restart JMRI now. So let's go to our sensor table. And because I've restarted without saving, our first sensor has disappeared. So let's quickly add that back in and make sure it's still working. Hardware address 1001. and that is SN1. Hit create. Okay, so in our sensor table, we've still got our first sensor. Let's add our second sensor. So it's going to be address 2001, and we'll call it SN2. And as you can see, it's come up as active. If we cover up the light as a light sensitive sensor, it goes inactive. We let the light in, it goes active again. So that's 2 nodes working on the CMRI network. Let's add a third. So for our third node, I thought I'd do something different again and try an Arduino Nano. So let's plug that into our breadboard down here. Okay, that's in. Again, we're going to need a TTL to RS485 adapter. So that can go up here. Again, we're going to need to connect our A connection to the CMRI network. So that can go in there. We've got our B connection on the green wire. So that one's going in there. Now we've got our RO connection going to RX on the Arduino Nano. We've got our D and RE connections being linked together using one of the small jumper wires. And then we've got our DI connection going to TX on the Nano. And then we've got the D and RE connections which are linked together going to pin 2, which is over here. Now again, we need to provide some power to the TTL board. So I've got connection to the 5-volt supply down here. Now the Arduino Nano doesn't have a 2.1mm socket, so we need to connect our 12-volt supply to the V-in pin, which is up here, and our ground pin, which is one of these. Down here. And onto the Arduino Nano, I've uploaded a sketch already, very similar to the sketch I uploaded to the Arduino Uno, except I've changed the CMRI address to 3. This means that the sensor that's going to be attached to the Arduino Nano will be on address 3001. Okay, so I've got a light sensor to attach to the Nano, so we need to attach this to the 5-volt supply. We'll connect this to the ground. And then we need this on connection number 3. So there's our little light sensor attached to the Nano. So let's go into JMRI. Again, go to Edit, Preferences. And we're going to configure another node. Add a node. The node address is 3. And we'll call this one Nano. Hit done, hit OK, hit done, hit save, and we'll just restart that. So in the tools, tables and sensors, add in our first sensor again. That's our first sensor in and working. So let's add our second sensor on the second node again. This one, and there we go, that's the second node working. So let's see whether the third node is working. So this will be on address 3001. Let's call this one SN3. And there is our third node and our third sensor. So there we go, that's how to set up a CMRI network using the RS485 to USB adapter, and how to connect the nodes using the TTL to RS485 modules and using a variety of different Arduinos. I know there were quite a few wires going all over the place there, but hopefully you were still able to follow along and pick up the principles of how you would add future nodes to your CMRI network once the bus wires were in place. If you want more information on how to use CMRI in JMRI, then there's loads of useful information on the JMRI website. I have to be honest and say this wasn't as straightforward as I was hoping. I had to restart JMRI a few times and reset the Arduinos just to get the nodes and the sensors to appear in the JMRI tables, which was a bit frustrating. Also, I noticed there is a slight lag between when a sensor is activated on the layout and when that appears in JMRI, which probably isn't going to be an issue for most people. It's only about half a second, but if that is going to cause you a problem, then you might be able to fix it by increasing the baud rate. And this was my first time using an Arduino Nano, and I have to say they're very impressive for their size. You get 12 digital pins, 6 of which can handle pulse width modulation for things like your servos and your light fades, and you've also got 8 analog pins on there. So these might be a good option where you want a node near a turnout where it can control the servo, the sensors and the signals all for that small area. If you found this video useful, then please give it a like and subscribe to the channel. Don't forget to hit that notifications button if you want YouTube to let you know when videos come out in future. Thanks for watching, and I will hopefully see you again soon.